I've shared my screen. Is it visible to both of you?
Yes, ma'am.
All right. So here it is, solve. We have two questions under that. The first one is find the value of the expression m squared plus 6mn plus 4 when m is 3 and n is 2. So the given expression is m squared plus 6mn plus 4. Write the expression, put an equal to sign, and the value of m is 3. So 3, m squared, so 3 squared, plus 6mn. So plus 6mn means 6 into m into n. 6mn means 6 into m into n. So 6 into 3 into 2 plus 4. You can put a bracket here to be safe because you'll have to multiply this 6 into 3 into 2. You should not add 2 and 4. So you can put a bracket. Next step, 3 square means 3 into 3, 9 plus 6 3s are 18, 18 2s are 36 plus 4. So this is 49. So the value of the expression when m is 3 and n is 2 is 49. Now the value of this expression will depend on the values of m and n. If you give different values for m and n, the value of the same expression will be different. When m is 3 and n is 2, the value of the expression is 49. Supposing m is 5 and n is minus 3, the value of this expression would be something else. So the value of this expression is not one fixed value because there are variables m and n in it. It will keep changing depending on the values of m and n. Next one is what will be the value of the variable m in m cubed minus n cubed is equal to 8. If n is 0, so we are given that m cubed minus n cubed is equal to 8. So this is the value of the expression. The value of the expression m cubed minus n cubed is given to be 8. M cubed minus n cubed is an expression. Its value is 8 is given. And n is 0. So that means n here. This is 0. So 0 cubed. Write the others as they are. M cubed minus 0 cubed is equal to 8. Now solve this. M cubed minus 0 cubed is 0 is equal to 8. I'll just continue here. So you'll get m cubed is equal to 8 because minus 0 plus 0 will not change anything.
Ma'am, so m is equal to 2.
Yeah, m cubed is equal to 8 can be written as 2 cubed. 8 can be written as 2 cubed. Why? Because 2 into 2 into 2 is 8. 2 into 2 into 2 is 8. That means 8 is equal to 2 cubed. 8 is equal to 2 cubed. So m cubed is equal to 2 cubed. So when you compare both the sides, m is equal to 2. When you compare both the sides, m is 2. What do you mean by comparing both the sides? We have m cubed is equal to 2 cubed, right? So like you can cancel the 3 and 3 here. So m is equal to 2. The value of m is 2. I'll just repeat this. It's given that m cubed minus n cubed is 8. The value of n is 0. So take n as 0. So you get 0. Write the others as they are. So 0 cubed is 0 in the next step. Now plus 0 minus 0 is not going to change any value. So you can just remove that in the next step. That minus 0, don't write it in the next step. So you will have m cubed is equal to 8. 8 should be written as 2 cubed. So when you compare both the sides, m is equal to 2. Understood? Both of you?
Yes, ma'am.
Okay. Form an algebraic expression for these statements. 5 less than a number. So you must say let the number be x. Let the number be x. 5 less than a number. So whatever comes after less than, more than, that should be written first. After less than, more than, whatever comes after less than and more than, that should be written first. So less than, after this, what do you have? A number. So you must write that first. Write that first. So x. Less than means minus 5. So x minus 5 is the required algebraic expression for this statement.
Okay, ma'am.
Yeah. You can call the number to be y also. Any letter you can use, A, B, C, D, any small letter. So you must first say let the number be x. Then the expression will be whatever comes after less than, more than, that should be written first. So less than a number, so write that first. And less than means minus, more than means plus. So less than, so minus, and 5. So x minus 5 is the required algebraic expression. The next one is 6 more than the sum of the ages of 2 children. 6 more than the sum of the ages of the 2 children. So you can answer this in 2 ways. One way is you can say let the age of one child be x. Let the age of the other child be y. So again, here you have more than. So I've told you whatever comes after more than or less than, that should be written first. So what comes after more than? The sum of the ages of the 2 children. So that will be x plus y. The sum means you should add. So what do you have after more than? We have the sum of the ages of the 2 children. The ages are x and y. Sum of the ages means x plus y. So you should write x plus y first. Then more than means plus. How much more than? 6 more than. So x plus y plus 6 is the required algebraic expression. Is the required algebraic expression. I'll repeat this. So since there are 2 children, you should say let one child's age be x, let the other child's age be y. Now sum of the ages of the 2 children means x plus y. Sum means add. So x plus y. Now after more than, we have x plus y. So we should write that first. And more than means you should add. Less than is subtract. So more than is plus 6. So x plus y plus 6 is the required algebraic expression. The alternate method is you can say let the sum of the ages, let the sum of the ages of the 2 children be x. Or you use some other letter. If you think again x it's confusing, you can say z or any other letter. Any letter you can use x, y, whatever. So say z. Let the sum of the ages of the 2 children be z. So z is not the age of one child. It is the age of one child plus the age of the other child. Together, the sum is z. So the sum of the ages of the 2 children, that itself we have taken as z. The sum of the ages of the 2 children itself we have taken as z. So then what will be the expression, children?
Ma'am, x plus y.
So Navneet, you're daydreaming. Huh? What x plus y? What are you doing, Navneet?
No, ma'am, nothing.
Where is x and y? We are talking the second one.
Oh, sorry,
Yeah.
sorry, ma'am. Got confused. Sorry. A, I saw.
You're right, Shri Harini. Very good. Z plus 6. Correct? Harini, that's what you said, right?
Yes, ma'am.
Very good. So Z plus 6 is the required algebraic expression. So we have taken the sum itself as Z. So, and one more thing is whatever comes more than, less than, that only we should write first. So after more than we have Z. So write that Z. Then more than means plus. So plus and 6. So Z plus 6 is the required expression. Yeah. So Harini, tell me the first one.
Ma'am, can I do?
No, you'll also get your chance. You can do B.
Okay, ma'am. Ma'am, first 4y plus y.
That I've already written. That I've already written. Continue.
Plus.
What do you mean by 4y? 4 into y, right?
Yes, ma'am.
So,
4 into y.
what is the value of y?
Ma'am, 45, ma'am.
So 4 into 45. Into 45 means you can put it in a bracket, or you can write 4 into 45. You can write 4 into 45. Then plus y. Plus y. What is y? 45.
45.
Then
Plus minus 7.
7. So what is 4 into 45? Okay, I'll do it for you. I'll do it for you. For 4 into 45 is 180. Then we should write the others as it is. Plus 45 minus 7. All right? Yeah, simplify this. Both of you simplify this and tell me the value.
Ma'am, it is plus 218.
218.
Yes, ma'am.
Okay. Yeah, next one, Navneet.
Yes, ma'am. So it's 12 bracket 3 minus 5 plus 5 is equal to 12 minus 2.
How 12 minus 2? I should write like this, is it?
No, bracket.
Instead of bracket, we can also use multiplication sign.
Oh, yeah.
12 into
minus 2 plus 5.
Hmm.
And
Minus
now we need to use the bottomless rule where multiplication leads. So minus 24 plus 5 minus 19.
Very good. Harini, next one. What's the value of m, Harini?
Mom, m is m, mom. M into 3, mom.
No, in the C subdivision, what is the value of m given?
3, mom.
3. So what is m cubed? 3 cubed, correct?
Yes, ma'am.
Plus, what is m square?
And 3 square 2, ma'am.
3 square. Then plus, what is 3m? 3 into m. 3m means 3 into m.
Into m.
Yeah.
Plus 3 into m plus 2.
No, you should not say 3 into m. You should say 3 into 3. You can put it in a bracket because 3 into 3 you should do. So you can put that in a bracket. Plus 2.
Plus 2.
Yeah. 2 you should write as 2. 2 should not be. Wherever there is m, you should use 3.
Yes, ma'am.
2 is 2 only. Wherever you see m, m should be written as 2. I'm sorry. M should be substituted with 3. Because m is equal to 3. It is given that m is 3.
Yes,
M is 3. So wherever there is m, 3. 3. Wherever there is m, it is 3. 2 will be 2 only. Yeah, now what is 3 cube? What is 3 into 3?
Ma'am, can I say? 9, ma'am.
No, 3 into 3 is 9. What is 9 into 3?
27, ma'am.
27. So 3 cubed means 3 into 3 into 3, which is 27. What is 3 square?
3 square 2, ma'am.
No, what do you mean by 3 square? 3 square means 3 into 3.
9, ma'am.
9. Then plus in the bracket 3 into 3.
9, ma'am.
Yeah. Then
Plus 2, ma'am.
plus 2. Yeah, so you can add this. 9 plus 9, 18. 18 plus 2, 20. 20 plus 27 is 47.
Yes,
Yeah, Navneet, D.
yes, ma'am. Ma'am, 4 into 12 minus 5 into 9.
Okay.
48 minus 45, which is 3.
Okay.
Yes, ma'am, that's it.
Yeah. Yeah. What should be the value of A if the value of 4x cubed plus 3x squared minus A equals 12 when x is equal to 0? So see here, we are given that, take this part, 4x cubed plus 3x squared minus A equals 12. Equals 12 means is equal to 12. We'll write that one. That's the equation given. We are given that 4x cubed plus 3x squared minus A equals means is equal to 12. And what is the value of x given? 0. X is 0. It's given x is 0. So you should write when x is equal to 0. When x is equal to 0, what will happen? 4 into 0 cubed,
0
correct?
square and
Plus
cubes.
3 into 0 squared minus A is equal to 12. So I'll write it again. When x is equal to 0, see, first thing is you should write this equation. First, you should write this equation. What is given? It's given that 4x cubed plus 3x squared minus A equals 12. Equals means is equal to 12. Write that. Then it is given x is equal to 0. So when x is equal to 0, when x is equal to 0, What is 4 into, what is 4x cubed? 4 into x. See, 4x cubed means 4 into x cubed it is. If there is no sign in the middle, it is multiplication. So 4 into x cubed, that means x is 0, 0 cubed, plus 3. 3x square means 3 into x square. But x is 0, so 0 square. Minus a, you should write a only. You should not put 0. X is only 0. A is equal to 12.
0 plus 0 minus a is equal to 12.
Yeah. So what is 0 cubed? It is 0. 0 cubed is 0. What is 0 cubed? 0 into 0 into 0, which is 0. Similarly, 0 square also. 0 into 0, which is 0. So what will be 4 into 0 cubed? 4 into 0. 4 into 0, which is 0. And what is 3 into, what is 3 into 0 square?
0.
3 into 0, which is 0. So this is 0 plus 0 minus a is equal to 12. So we have minus a is equal to 12. Change the signs on both the sides. Changing signs on both the sides. We have a is equal to minus 12. The reason is changing signs on both the sides. Changing signs on both sides. A is equal to, change the signs on both the sides. That is, minus a will become plus a. Plus 12 will become minus 12. We have minus a, write it as plus a, equal to, we have plus 12 here, write it as minus 12. That is what is changing signs on both the sides. So a is equal to minus 12. The value of a is minus 12. Understood? Any part you don't understand, please ask me, both of you.
No, ma'am, no doubt.
No doubt, ma'am.
Okay. Harini, tell me what is minus 7 into 0. What's the answer? What's the value of this one?
0, ma'am.
Why?
Ma'am, because we will do my 0 into 0 2 times, ma'am. So it will, we can't multiply 0 into 0, ma'am. So the answer will be 0, ma'am.
Correct. So 0 square is 0. Then into minus 7. 0 square is 0. This one is 0. What is minus 7 into 0? Anything multiplied by 0 is 0 only, no? So 0. Yeah, anything multiplied by 0 is 0 only. So 0 into minus 7 is 0. Yeah. In class and because it's certain chapters, you know, I will do in class and workbook. Now this chapter is not very, meaning this particular concept is not really difficult. It's just numerical work. So I'm not doing the in class. You do it as homework and we'll check the answers when you come to the next physical class. So this is homework. Similarly, the workbook also. We'll see the answers. Work it and we'll see the answers in the next class, in the next physical class.
Okay, ma'am.
Okay. Yeah. Draw a factor tree and identify the terms and factors of the given expressions. How much have they finished for you, Harini? This chapter is over.
No, ma'am, they completed till LP3 only, ma'am.
LP3, yeah?
Ma'am, for me they finished.
Okay. All right. So for drawing a factor tree, to draw a factor tree, you should write the expression first. The given expression is the given expression is 15xy plus 4x square y plus 10. Now there are three terms, 1, 2, 3 terms. So make 3 branches. So see here, just put a line like this, 1, 2, 3. Take 3 branches like this. You can use arrows. If your teacher uses arrows, you can use arrows. Because there are 3 terms, 1, 2, 3 terms, I've taken 3 arrows like this. 3 branches like this. Now in the first one, write 15xy. In the second one, write 4x square y. Because the sign is plus, we are not writing. If it was minus 4x square y, we'll write the sign. Because it is plus, we are not writing. Supposing it was minus 4x square y, we'll write the minus sign also. Then 10.
And then 15xy.
Then further in this one, we see 15x and y. So branch it. We have to take 3 branches. So 15x, y. Here, you can write x square as x into x. Write x square as x into x. So we'll have to take 4 branches. 1, 2, 3, 4. 4x, x,
and
y. And 10, you can just leave it like that. So you don't have to branch out further for 10. If you have to make odd branches, you should start with a line in the middle and then keep doing this for odd number of branches. If you want even number of branches, then you should start like this. Then you should go on like this. I hope you understand. See, I'll do this and show you. In 15xy, we have to branch out for 15x and y, 3 terms. So I'll start like this, 1, 2, 3, 15x and y. But here 4 terms, 4, x square is x into x and y, 4, no. So don't start with a straight line like this. Don't start with a straight line like that. Start like this. Start like this. 2, 4. So you write 4 here, x here, and y here. Understand?
Yes, ma'am.
Yeah. So against this one, see, this is the expression. These are the terms. And these are the factors. Okay, so you have to write them down again. You have to write. So this is the expression given. This is the expression given. These are the terms. All these 3 are the terms. These 3 are the terms. And these are the factors. All right. So your answer you should complete like this. You must write. The question is write the terms and the factors. So terms are terms, or you can just put a colon. Terms 15xy, 4x square by 10. Factors you must write for everything separately. So factors of 15xy. 15x and y. Then factors of 4x square y. 4x, x and y. Do we understand how to present the answer?
Yes, ma'am.
The question is to write the terms and the factors. So the terms are, you should write the terms with the sign. Because it is positive, we are not showing it. If the signs are negative, you'll show the sign also. So there are three terms. 15xy, 4x square y and 10. Now you should write the factors of the terms. You must write the factors of the terms. So the first term is 15xy. Factors are 15x and y. The second term is 4x square y. Factors are 4x, x and y. The third term is 10. Actually, we do it in a different way, but I'm just teaching you as per exceed. Now for the other school students, I do it in a different way. So for exceed, this is how we learn in exceed. 10 can be written as 2 and 5. 10 is equal to 2 into 5. But in exceed, they'll only factorize the algebraic parts, not the numerical parts. The numerical parts meaning 15, 4 and 10. 15 can be written as 3 into 5. 4 can be written as 2 into 2. And 10 can be written as 2 into 5. But you see that in exceed, they don't factorize the numerical portions. Only the algebraic part is factorized. So that's what even I've told you. Understand, children?
Yes, ma'am.
Okay. Now tell me for B then. You must write the expression, right?
Yes, ma'am.
What is the expression? 6a square b minus 5ab square. Now, how many branches should you take?
2, ma'am.
Only
4.
2 branches. 1, 2.
Branches of, yeah, 2 branches, yeah.
Yeah. So 6a square b and minus 5ab square.
Yes, ma'am.
Yeah. So here, how many factors we'll have? 6 is
4.
6 only. I told you in exceed, the numbers are not factorized. 6 is 6. 6 is actually 2 into 3. But in exceed, we write 6 as 6 itself. So 6. The algebraic terms are factorized. A square is A into A. So 6, A, B. So we need 4 branches.
Yeah.
So you start like this. 1, 2, 3, 4. 6, A, B. Okay. And here, how many branches?
4.
Minus
4.
5, A, B, B. 4 again. 1, 2, 3, 4. Minus 5, A, B, B. So these are the terms. These are the terms. This one and this one are the terms. So we should write terms here. And these are the factors. So you must write factors here. You must write factors here. So what is the question? You should draw the factor tree. Now what we have drawn is the factor tree. What the diagram you see is the factor tree. Draw a factor tree. So that's what we have done. We have drawn the factor tree. And you should identify the terms and factors. So you must write now. See, factor tree we have drawn. What is the question? Draw the factor tree. Okay, we have drawn the factor tree. Identify the terms and factors. So what are the terms? Terms are 6a square b and minus 5ab square. These are the two terms. Now for the two terms, for each term, you should write the factors. So you must write factors of 6a square b. We have done here, no? See, we have done here. Factors of 6a square b. What are the factors?
Ma'am, 6A, and B.
Correct. Next,
Ma'am,
what
I
you do that?
I have one doubt, ma'am. We have
Yeah.
already written it there. Then why do we need to again write it?
No. That's how we draw a factor tree. In a factor tree, you need to show all this. These are the parts of a factor tree.
Yes, ma'am. Okay.
That is only the factor tree. See, this whole thing is only the factor tree. 1 second. See, this entire thing is how we make a factor tree.
Yes, ma'am.
Then there's a question, no, draw. See, if the question is, that's what, yeah. If the question is draw a factor tree, this box you should, whatever you see in the box, you must show. Then identify the terms. So you should write the terms below.
Oh, okay.
So supposing they ask you only to draw a factor tree, still you should write all this. You must write expression, terms, and factors. These are the parts of a factor tree. This and whatever you see in this box are all about the factor tree. Yeah. We have not written expression, terms, factors because they've asked us to write all that. No. Only for factor tree, you should write all this. Yeah.
Okay.
So terms of, okay, factors of 6a square b we've written. Next, what, Harini, factors of? Harini, say.
Ma'am, factors of minus 5ab.
Is okay. Are what?
Minus 5, comma a, comma b, comma b.
Yeah. So sometimes your teacher will say put and, all that you take your teacher. Supposing she says 5a, b and b. Okay, you write and b. That's okay. Or you can put comma b. Okay, no doubt, right? Both of you?
No doubt, ma'am.
Okay.
No doubt, ma'am.
Okay, so both of you agree that this is simple, no? The concept here is very simple, right? So don't you think you can try the in-class and workbook by yourself?
Yes, ma'am.
Yeah, because I shouldn't be spoon feeding you. When you need an explanation, mostly we see like the lesson 1, I did everything because then only you will have the clarity. Teaching 3 sums, you will not get the clarity. That's why for lesson 1, where we had to, construct the pattern and write the rule for the pattern. There I did all, meaning we did PQs in class and the workbook, we did it together. Why? Because I think workbook I gave homework.
Yeah, no, ma'am. You did the third questions of everything, like in class speeches and word
Correct.
book. You did third question. Others you gave us homework because those
Correct,
were
correct.
simple.
Yeah, correct. So like that. So if it needs an explanation, I'll not give it as homework. Only if I'm very sure you can do it as homework, I'll do that. So these concepts are very simple. You should be able to do it by yourself. So this is lesson 3. I'll just give you the introduction with the examples. So the rest of it, the in-class and the rest of it, you should do it as homework.
Okay.
Yeah. Okay. And there is one more example in lesson 3. Yeah. What are the coefficients of x in the following expressions? Can you recollect what your teacher told you?
Yes, ma'am, I know. Ma'am, I remember.
Yeah, okay. Tell me, Navneet.
Ma'am, the coefficients are 2.
2.
Ma'am,
No,
yeah.
no.
2, 5, and
No. The question is what are the coefficients of x in the following expressions? X. So
2.
wait. The term, this is the answer. The term containing x is minus 5xyz. The coefficient of x in the term minus 5xyz is minus 5yz. This is the answer. See, first you should identify the term that has x. Which term has x here? Minus 5xyz. That term has x. So the term containing x is minus 5xyz. Now write the coefficient. The coefficient of x in that term will be minus 5xyz. No, don't write x. Write everything else. Minus 5yz. The coefficient is minus 5yz. Don't write that x. Minus 5yz is the coefficient. Do we understand or no?
Yes, ma'am.
Yeah. Navneet, probably you're getting confused with something else. So this is what it is.
Okay.
When an expression is given, you should find the terms that have x in it. So here only the second term has x. So write that the term containing x is minus 5xy because the first term does not have x at all in it. Only the second term has x. So the term containing x is minus 5xyz.
Okay, ma'am.
And the coefficient of x in that term, the coefficient of x in that term will be, the coefficient of x in the term minus 5xyz is, don't write x, minus 5yz. Okay. So in the second one, the term containing x is which one?
Ma'am, y square 2x.
Ma'am, y square x.
Yeah, correct. It's y square x. Now you should
So
write the coefficient.
the coefficient
Of x.
of x is y square.
No, in the term.
The term y square x is y square.
Correct. Okay. Yeah, the others you can do. Okay. Find the like terms from the given set of terms. So some terms are given to you here. 2m minus 5m square n, 3xyz, y square x minus m, 4n square m minus 3xy square. There are so many terms here. So if you have to pick the like terms, they must have the same algebraic factors. Like terms have the same algebraic factors. Meaning, the meaning of that is, see, like if you have 15x squared y, this is called the numerical factor. 15 is the numerical factor. The algebraic factors are this one, x square and y. Factors are of two kinds. Numerical factors, algebraic factors. The number is a numerical factor. Algebraic factors are those letters, A, B, C, D, X, Y, Z, those letters. So if the terms have the same algebraic factors, then they are like terms. Like terms have the same algebraic factors. So in the, yeah.
Ma'am, can I say one like term in this from this? Ma'am, y square x and minus 3xy square.
Correct.
Mom, I can't understand you, ma'am.
No, I haven't finished explaining. He answered before that. I haven't finished it. So now I said like terms have the same algebraic factors. Now, when you look at this one and this one, don't see the numbers. There is y square here. There is y square here also, no? Yeah. There is x here. There is x here also. Leave the number. We are not looking at the numerical factor, only the algebraic factors. So these two terms have the same algebraic factors. We'll see again. See. We'll see again. When so the answer is this one and this one, they're like terms. Why? Because here there is y squared, here also there is y squared. Here there is x, here also there is x. They have the same algebraic factors, so they are like terms. Yes or no?
Yes, ma'am. It doesn't matter if they are not in the same order.
Order doesn't matter. Order does not matter. Correct. The numerical factors also don't matter. Only the algebraic factors. Like terms have the same algebraic factors. So the answer for this one is y square x and minus 3xy square are like terms. One more set also you can find. You can find one more. Look at this one and this one. M.
Yes,
M.
ma'am.
M.
Yes, ma'am. Literally just minus 1m. They have written as minus m.
Correct. So M. So 2m and minus. We are not worried about the sign or the number. Any sign it can be, plus, minus, any sign, any number it can be. It may not have number also. The algebraic factors, that is the letters, must be exactly the same. M. So 2m and minus m are like terms. If you look at this one and this one, they are not, because this is m square, but this is only m. This is n, but this is n square. So they are not like terms. The algebraic factors must exactly be the same. Correct?
Yes, ma'am.
Now understood, Harini? Am I clear now?
Yes, ma'am.
Okay. Yeah. Write three terms that are like terms to minus 3 p q square r. So the terms which you write, no, they also should have p q square r, but order can be different. See, the first term can have q square p and r. The second term can have r q square and p. The third one can be r p and q square. So you can put, see, just for you to understand, I have written the factors in different orders. The same factors p, q square, r in different order. Everywhere you have p, q square, r, p, q square, r, p, q square, r. Everywhere you have the same factors. That's why they can be like terms. Now you can put some number before these factors. So you can just say minus 7 and then something like 9. You can just put, you can write 4 by 5, anything. Or if you don't want to put any number also, it's fine. You understand how to construct?
Yes, ma'am, but the square cannot be changed. The square, the PQ square.
No, they were the same. No, see here, I wrote, see, let me just start with a number. I start with a number minus 9. Now I'll write, see, I'm writing q square. I'm writing p. I'm writing r. Correct?
Yes, ma'am, but the squares cannot be changed. No, like q square cannot, that square could not go to the other square. No, can't be like minus 9q p square r.
No. Q square should be q square.
Yeah, that's what I'm telling. It cannot be like that.
Yeah. Now you tell me one more, Harini. I'll just start with 3. 3r, you complete it. I'm writing 3r. You complete this.
Number. Q square 0.
Very good. Tell me one more, Harini.
3.
I'll just put a minus sign. Minus.
3.
Minus.
3.
3. You can't write the same number. Minus 3 is already there in the question, no? Don't put any number. Simply minus.
Square 3. Sorry, square 2. Square num. Q square.
Q square.
RP.
RP. That's all. So these are 3 terms that are like terms to minus 3p q square r. You can write anything. See, you can even write fractions. You can write 4 by 5 p q square r. Then you can write whatever. See, that's what I'm saying. There's no, you can write 0.3 q square rp minus 1 by 3 or minus 1 by say 8 r q square p. So basically the letters must be the same. These letters, numbers can be anything. Numbers can be decimal numbers, fractions, positive, negative, anything. But if you write 0 p q square r, this is wrong because 0 means the whole thing is 0. 0 into anything is 0. So you cannot write this one. You cannot write 0 pq square r because 0 into anything is 0. This entire thing is 0 then. And again, it's not that you should change the order and write. Not that you should always change the order and write. You can write in the same order also. You can write like 2 pq square r, 3 pq square r, 10 pq square r. You can write it in the same meaning without changing the order of p, q square and r. You can do that also. Not that you should change the order. You can write The same order, P, Q square, R, P, Q square, R, P, Q square, R, and different numbers as the coefficient, numerical coefficients. So you write any three. Understood? Like terms, they must have the same algebraic factors. The letters must be the same. Numbers can be anything.
Yes, ma'am.
Okay. Now, how will you write? 1 second. Yeah. Now, how will you write unlike terms? Supposing you're asked to write one term unlike to, I ask you to write a term unlike to a square b square, 5a square b square. How will you write that?
Ma'am, we can write like any formula like 4z
Any
square.
expression, not formula, any expression.
Any expression like 4z square and p cube. P cube.
Yeah, this itself is in a 4z square. You can write 5ab. You can write 5a square b, or you can write 5ab square. All these are unlike.
Yes, ma'am. Like anything we can write.
Yeah, the expression you write should not have a square b square.
Yes.
Anything other than that it can have. See, 5ab and 5a square b square, they're not like terms because this is a square b square. This is only ab. So they are not like terms.
Yes, ma'am. So if we write also like 5a square b cube, still it's not same.
Yeah, if you write 5a cubed b square, it's not, it should be exactly the same.
Yeah.
The algebraic factors, the letters must be exactly the same. A square b square means it should be a square b square only in the others. Now this is a cubed b square. No, they're not like terms. So if I give you a term like 5a square b square and ask you to write one term which is not unlike to this one. So you should just you can write 5. You can write a square, but don't write b square. Write b or write b cubed. You can write 5z or you can write minus x, anything, but not a square b square. Correct? Understood? Had any like terms and unlike terms?
Yes, ma'am.
Now tell me if these two terms are like terms. Fast you must say. Are they like terms or unlike terms?
Ma'am, like terms, ma'am.
Like terms. Very good. Navneet, are these like terms or unlike terms?
Ma'am, these are like terms, like terms.
Like terms because z, y cubed. So they're like terms.
Yes, ma'am.
What about these two? Are they like terms?
No, ma'am.
No, because they're not exactly, they should be exactly the same. A, B, this
They
is
do
A
not have
square.
squares on it. They do not have squares on it.
Yeah, so they're not like terms, they're unlike terms. Unlike terms. Okay. So with this, we complete block 21, understanding block 21. We have not completed in full. You have to do all the homework and we'll, check the answers. So with that, it will be complete. So now you have a good idea about the whole chapter. So this will help you to complete the assignment, right? Are you confident, Navneet and Harini, to do the assignment?
Yes, ma'am. Very easy chapter to us.
Okay, good. So now, Harini, today's class I've shared all the images, okay?
Yes, ma'am.
Now what the homework is, you must complete everything. This block you must complete like all the examples, PQs in class and workbook. Some, yeah, those which we have discussed, you have the answers also, both of you, Navneet and Harni. So whatever we have discussed in the class, I've shared the images, so you have the answers.
Okay.
The others, yeah, the others will be homework, and that you should be able to do correctly. If you've understood the classes well, you will be able to do the homework correctly. All right?
Yes. Yes, ma'am.
Okay. Okay. So I'll let you know about the next class. Try to complete. Okay. So maybe you'll have a class tomorrow. I'm not sure. So today, Harini, if you have time, try to start working the assignment. All right.
Yes,
Do it in the order. Both of you do it in the order. Start from lesson 1. So lesson 1, write the examples, PQs, in class and workbook. Then go to lesson 2.
We already finished. You sent the images and we finished it already.
Oh, right. Oh, lesson 1 is over. Oh, I'm sorry. Okay. Lesson 2. See, whenever you take up a lesson, no, you should always do it in this order. Example, PQs, in class, workbook. Then go to lesson 3. So when you go to lesson 3, again, examples, PQs, in class, workbook. Always maintain this order. Because when you take a lesson, you should finish it in full. All right?
yes,
Okay, so in this order, please start doing the homework. I'll let you know about the next class tomorrow. Okay? Yeah.
yes.
Thank you,
ma'am.
Harini. Thank you, Navneet.
Thank you, ma'am.
Thank you, ma'am.
Thank you, Harini. See you.